Hello everyone, I am Anikate Koul and today we'll be discussing the 16th problem from the CP-31 sheet by TLE Eliminators under the 1200 rated questions. So I'll be moving to the CP-31 sheet and we can see that the 1200 parameter has been checked. So I'll be moving down to my 16th question. You can find a clickable link to our problem, Stone Age problem. So let's begin. The problem statement is as follows. Once upon a time, Mike and Mike decided to come up with an outstanding problem for some stage of ROI, which they say is rare Olympiad in informatics. So one of them came up with a problem prototype, but another stole the idea and proposed that problem for another stage of the same Olympiad. Since the first Mike has been waiting for an opportunity to propose the original idea or some other contest, Mike waited until this moment. So this part is not necessary for the question. The actual question starts from here. You are given an array A of n integers. You are also given q queries of two types. The first query is to replace ith element in the array with integer x. The second type of query is replace each element in the array with integer x. Now after performing each query, you have to calculate the sum of all the elements in the array. Right, now the input format of the constraints is as follows. The first line of the test file contains two integers n and k, denoting the size of the array and the number of queries respectively. Both of them can go up till 2 in 10 power 5. The consecutive lines, that is the first line for every test case, would contain n integers denoting the array, and every element can be between from 1 to 1e9. Now each of the following q lines contains a respective query. So for the first query, the format is as follows. The first number would be 1. Then you would have two integers I and x denoting the index of the value that you have to change, and the x, which is the value you change it to. If the query is of the type 2, the first integer would be 2, and then you'll have another integer denoting x, which would mean that you have to change all of the elements in the array to x. In both cases, x can go up to 10 power 9, and I, as it denotes the index, will be between 1 and n. Now in the output you have to print q integers, and the ith integer will represent the sum of your array after the ith query. So as we have read the problem statement, we can understand what it actually means. Now for every test case, we would have a few things. We would have an n, a, and q. So n is an integer, a is an array of size n, and q are the queries. Right. Now the queries can be of two types, type 1 and type 2. Okay, for type 1, you would have it of the form 1, I and x. Type 2 would be of the form 2 and x. 1, I and x represents that change a of I to x. 2 of x means that for all I that belong to 1 to n, here this is the one-way indexing, change a of I to x. This is the difference between the two types of queries. And after each query, you have to output the sum. So sum of ai, where I goes from 1 to n. You have to output this after every query, right? So you'll be outputting n integers. This is your question, right? So let's take a sample case to understand it better. We have this lone sample case here. Let's take it and paste it here. I'll remove an extra part, and let's also increase the font size so it is visible better. Right. Now this is my n and this is my q. This is my a. Right. And these are the queries. So this is a type 1 query, this is a type 2 query, type 1, and type 2. So let's calculate the initial sum. So the sum 0 is basically the sum at the 0th query or before all the queries, let's say. So that would be equal to 5 plus 4 plus 3 plus 2 plus 1. That is equal to 9 plus 3, 12, 15. Sum not is 15. Sum 1 is how much? That is after the first query. In the first query, what we are doing is a of 1 equals to 5. So the new array now is 5, 2, 3, 4, 5. So the sum here would be 5 plus 4, 9, plus 3, 12, 14, plus 5, 19. Right. Sum 2, let's calculate what it is. The second query is 2 and 10. So that means our new array would be 10, 10, 10, 10 and 10, because the second query will be replacing all the values in our array with this given value, that is 10. So the sum here would be 50. Great. Sum 3 is after the third query. So in the third query, what I do is I replace the last element with 11. So now it becomes 10, 10, 10, 10, 11. And that is 51. Sum 4, that is the sum after the fourth query, is, let's see what it is. Here we are changing the fourth index to 1. So 10, 10, 10, it is 1, yes, 11. This is 30, 31, 42. And sum 5 is changing all the elements to 1. So that will make our sum equal to 5. Now we don't have to output sum 0. We'll only have to output these sums. 1950, 51, 42, 5. And 1950, 51, 42, 5. That is exactly our answer. So this is how our question frames. Now let's discuss the expected time complexity. If we see our question, we find that there is actually no constraint over the sum of n over all test cases, because there is no test case actually. Yes. So that means our time complexity would be of the form f of n into f of q. Right. Now we'll see how these frame out to be, but we know that the number of operations have to be less than 10 power 8, because 10 power 8 is the limit on the number of operations we can run in 1 second on Codeforces. Right. Now we know that n can go up till 10 power 2 and 10 power 5. I hope I am right with that. Yes, it is. And q can also go up till 2 and 10 power 5. So we can say one thing, that if we do O of n into q, that goes 4 into 10 power 10, and this will definitely not run. But we can do something like O of n. That means if we run every query in constant time, that will give us an O of n time complexity. And actually it is better to denote it with O of n plus q, because we would have to at least run over every query once. So it won't be n into q, but n plus q, and that would be around 4 into 10 power 5, and this will run perfectly fine. We could also run something like q log n plus q log n actually. So again, write it in a better way, n plus q log n. And this would be somewhere 2 into 10 power 5 plus q is 2 into 10 power 5 into 20 approximately, because log base 2 of 2 into 10 power 5 is approximately 20. And this would be around 4 into 10 power 6. Right. This would also run pretty comfortably. So we want somewhere, the expected time complexity has to be somewhere in this vicinity. Right. Now, as you have discussed the expected time complexity, let's move on to the solution. So what is the major issue in solving this problem using brute force? So what would the brute force be? Right. What I could do was, let's talk about a bit more optimized brute force. The basic brute force is that for every query, you update your value. So if it's type 1 query, you perform the operation a of I equals x, and then iterate through the whole array and calculate the sum. Right. Or for type 2 query, you go on every index for all I, you do a of I equals to x, and then iterate again, calculate the sum. This is the basic, very basic brute force. A better way to optimize it would be for type 1 queries, you do ai equals to x and update the previous sum. So the previous sum would be equal to sum plus x minus original a of I, right? So first do this, then update the value, right? So in this case, for the type 1 query, you would take only O of 1 time. Here you are taking O of n here and O of n here. But again, for type 2, you would have to update all the values. So in any case, it would take O of n here, right? So in the worst case, there could be all type 2 queries. So there what would happen is you would go into O of n into q. And this we knew won't work, right? Now let's try to optimize it. Let's try to optimize the time we take for every query. Right. Now this is pretty simple. We are able to understand it. But the issue is that let's say I had type 1 query. So let's make an initial array. The initial array is 1, 1, 1, 1, 1. So n is equal to 5. Right. This is my initial array. Let's make a type 1 query on my index 2. This is one based indexing still. Index 2, and let's update it with 5. Right. Now, what my array would look like? So my array would look like 1, 5, 1, 1, 1. Right. Now, to do this in O of 1 is pretty simple. You just change 1 to 5 and your initial sum was 5. The new sum would be 5 plus 5 minus 1, and that would be equal to 9. And you can check 1 plus 5, 6, 7, 8, 9. 9 is the sum. This is pretty simple. But the problem comes when you are integrating the second type of query as well. So let's say in the type 2 query, I change all the values to 2. So now my values have become 2, 2, 2, 2, 2. Now calculating the sum is the easy part. If you don't have to update the array, if you don't update the array, the sum is just 5 into 2, that is equal to 10. 5 is the size of the array and 2 is the new x that you had in the type 2 query. This is easy. But let's say after this you had another query of type 1 and that was 1, 3, 4. Then how do you know what was the value present here at index 4? Was it 2 or was it the value that was originally present? 1, right? Because if you want to update the whole array, you would take O of n time, and that is not possible, as we saw in the worst case. That would lead us to a TLE. So how do we tackle this problem? There is a very nice solution to this. What do we do is, instead of storing a simple array, we store a vector of pair. A vector of pair of int comma int. Right. Now let's see what it will store. So the dot first will store the value, right? So this is the value at the current index, or as you know, we denoted it using the array was a, right? So I can say that dot first is the value or the a of I, right? But dot second is the query number when it was last updated. So dot second would store the query number of the query where this index I was last updated. Along with this, we would store another variable, let's say global val, and this will try to handle the type 2 query. So this would also have the data type of pair of int comma int. Again, dot first would be representing the latest x that we had. So the latest value to which we updated the whole array, and dot second would again represent the same thing, the query number when it was last updated. Now, it may be a bit confusing at first, so let's try to visualize using the same sample case how it actually works. So let's copy the above sample case. Where is it? Yes, it is here. So let's copy this and go down, paste it here. Let's move to a bit side. Great. So now my new array, which is a vector of pair, would be something like this: 1 comma 0, 2 comma 0, 3 comma 0, 4 comma 0, 5 comma 0. Because initially no value has been updated by any query, so I'll say that the last query that updated this value was 0, right? And the global val, let's say it was 0 comma minus 1. It was updated in the minus 1th query, right? And it has, now its value doesn't matter because it can it is the least value, so it is not the latest, and you will get to know how the value here would not affect anything. Let's see. In the first type of query 115, what I do is I update the first value, so I change it to 5. The dot first is basically the a of 5. I change it to 5, and the dot second is the query number where it was last updated. So this is the first query, right? This is the first query. So I do it like this: 5120304050. Right. Calculate the sum is pretty easy. As I said, it would be the original sum, that is 15, minus the new x minus the original value. So that is equals to 15 plus, sorry, this is plus 15 plus 4, that is 19. We got the value, that is O of 1, no issue. And this update is also O of 1. Now the next query is 210, right? Now this query will update the global val. So global val becomes 10 comma 2, because 2 is the second query, right? So this is the second query. So dot second becomes 2, and dot first is the latest val, so it becomes 10, right? Notice here that we don't change anything in our array or in our vector. We don't touch it. Now we'll get to know what this global val actually does. Let's come to the next query, right? It is 1511, right? Now what we'll do is first try to calculate the change in sum. So this was second query, right? Let me write the sum here. The sum would be the size of the array is 5. So sum would be 50. It is very simple to calculate the sum. In this case, O of 1, n into x, that is 10 into 5, 50. Now coming to the third query, let's first calculate what the new sum would be, right? For that, what I would do is 50 plus original value, so not the original, sorry, the x that I had in this query minus original value, right? So my 50 is same. X, what is x? The third query, x is 11 minus the original value. Now what is the original value of that position? So that position is basically the fifth index. What is the original value? Is it this, that 5, or is it this 10? How do I know? Because I want to calculate this in O of 1 time, right? So here the dot second comes into play. Now compare the dot second values of both the array and the global val. Whichever one is the highest, that means that one is the latest, right? This value was updated in the 0th query. That means it was not updated at all. But this value was updated in the second query. That means this is the latest change. So the current value of my index would be 10 and not 5. This is how it works. Pretty cool, right? So my original value in this case would be 10. 50 plus 11 minus 10, that is equal to 51. And now I update my array. So my new array is 5120, and this should be 3040, and what is the new value? It is 11, right? So 11 comma 3, because it was updated in the third query, right? And the three queries are done. So let's check the fourth query. So in the fourth query, I want to update my fourth index to 1. Again, what would be the new sum? It would be 51 plus my x is 1, minus original value. Now what is the original value? Let's see. Is the original value this 5 or this 10? How do I know? So let's check again. The dot second value here is 2, dot second value here is 1. So that means this is the latest change to my first index. So that's why my original value would be equal to 10, right? So I would write a 10 here, that is 51 plus minus 9, that is equal to 42. My new sum is 42. Again, update our array. So this is 1 comma 4, because this was updated in the fourth query, 20, and now it is 3040 and 11.3. And now let's come to our last query, which is 2 comma 1. So what I'll do is update my global val. Global val is equals to 2 comma 5, because it was updated in the fifth query and the value is 2. My sum is simply n into k, that is 2 into 5, that is equal to 10, and hence my sum is equal to 10, and the array won't be changed because this was a type 2 query. So this is how my solution and algorithm works. Now let's come to the time complexity. The type 1 query, takes O of 1 time to be calculated, because you have to just change one index, nothing else. And the calculation of sum is also O of 1, because we are just accessing some variables in an array. Type 2 query is also O of 1, right? Because we are just changing the global val and the sum is calculated in O of 1 time as well. So per query is just O of 1 time. Therefore, total time complexity is O of n plus q, right? And as we discussed, this will run pretty easily. So I hope you have understood the solution. Now let's move to the implementation part. It's pretty simple. The same thing that I discussed. So this is n and q, the size of the array, number of queries, taking in the input, defining the new array. So the pair array, I'm taking input, there's a dot first part, right? Because that is the a of I that I discussed. So I'm just taking the dot first input, and dot second would be 0, because I did not update any value up till now. So this takes O of n time. Now again, the global value as I discussed, it would be 0 comma minus 1. This is my sum. This is a running value. It will store my current sum. Now I initially calculated before any query is executed. So this loop is also O of n. Now for every query, what I would do, I would take in first the first value. So either it is 1 or 2. So if it is 1, that means I have to take an input, the index and the value. So I take the input, the index and the value, ind minus minus, because the index is in 1 based indexing. So I have to subtract 1 to make it into 0 based indexing. Now again, I compare the dot second values of my array and the global val. So if the array dot second is higher, that means the current value in the array is latest. So therefore, my sum would be increased by val, that is was the x minus the original value, right? Pretty simple. Otherwise, if global val dot second is greater than v of in dot second, that means the global val has the latest value. So my new sum would be val, that is the x, minus global val dot first, right? Pretty simple. Now, after this change in sum, I update my array. So v of in dot first is val, that is x, and v of in dot second is the it, that is the current query number. Otherwise, let's say it's a type 2 query. What happens then? Then I just take in the value of the val, that is the x. Now, global val dot first is the x, global val dot second is the current query number, and the sum is basically equal to the x into n. Val is the x, as I discussed. Just remember to put a long here, typecast into a long, because your values the sum can go up till 10 power 14 or 2 into 10 power 14, because if you see the constraints, the n is 10 2 into 10 power 5 and here is 10 power 9, so it would be around 2 into 10 power 14. Remember that. And then after the end of each query, just output your sum. So this loop also runs O of q times, right? Because we are running a loop of q. So if we discuss the total time complexity, the total time complexity comes out to be O of n plus q, right? Because we are running a few O of n loops here and one O of q loop here. And the total space complexity is just O of n, because you're just storing a vector of pair array of size n. So I hope you like the problem. And for the final remarks, I would say this problem was quite interesting because it used a uh, different kind of data structure to store the queries. So this observation was quite necessary, that as to how would you optimize both the type 1 and type 2 queries. So this was the way that without updating the whole array for the type 2 query, you just check the version of your update, right? Similar to what you have in your mobile phones. So they check the software version with the server version. So similar kind of thing goes here, that you check the versions of the updates of your global val and the array value, and whichever is the latest will override the value. So I hope you like the problem. Thank you.